Day 37, Honors Physics, Newton's Three Laws, Example 22. One of the sticking points on this problem is maybe just getting started. There are 3 or 4 things that it talks about in this problem. It's talking about a car, it's talking about a person, it's talking about seat belts. There's probably a second car that the first car is hitting. But what we want to focus on is the person. It's asking about the person, the forces on the person. So we don't really care about the other things. We really don't even care about the seat belts. The seat belts are what are applying the force, but they're not the object on which a force is applied as far as solving the problem. Yes, there is a force on the seat belts that would be opposite and equal to the force that the seat belts exert on the person. That's Newton's third law. But we're just looking at the person here. So here's the free body force diagram for the person. 800 newtons of weight, 800 newtons of normal force holding the person up, and the force that's responsible for stopping the person in the accident is the seatbelt force. I labeled that in blue. There's probably a little bit of friction between the person and the seat as well. We're ignoring that. But the predominant force stopping this person is a seatbelt labeled F. And it's just, at this point, essentially just a straightforward F net equals MA problem, where F net is just the F equals 80 times A. Now, it seems like we don't know A, but once again, there's enough clues in here, and we had a problem, I think, similar to this a while back, but we're going to use uniform acceleration. I'm doing this kind of backwards here. I'm going to go over to the left. In other words, V sub I is 12 meters per second. I assume the car was moving to the right. Doesn't really matter, because if you're moving to the right, you would need a force to the left to stop you, but this one doesn't really, the direction doesn't really matter that much in this problem. We're looking at magnitudes mostly. But the car has got a speed of 12 meters per second. It's going to come to a stop, 0 meters per second. We're looking for A. S is 3 meters, and then T. So just like I think the other problem that we had, we're just going to plug into that equation, the uniform acceleration equation, which is our 4th one. Vf squared equals Vi squared plus 2AS, where Vf is 0, squared is 0, equals 12 squared, which will be 144, plus 2 times A, unknown, times S, which is 3. So solve that for A, and then plug that in up here, and that will give you the stopping force, F, and it'll come out negative. You don't have to use the negative, but once again, the negative would indicate that it's opposing the motion of the car, which in my diagram is implied to the right. The force is to the left.